Suppose now that we have a cube box that has length of 6 centimeters, and we apply a force of 0.2 newtons on this direction, like this. So it is a shear force that is a shear force that is doing this, like the friction, and we produce a displacement of this sheared face of 0.5. So now the box would be, this face is fixed, and so now we have it something like this. Something like this. The displacement was 5 centimeters. So from here to here are 5 centimeters. And remember, here we have a distance h. I'm already helping you. H here 6 centimeters. We want to find what is the shear modulus. Alright, if you think you can do it, stop the video now and let's continue to see we have the same result. The shear modulus is the shear stress divided by the shear. One is shear and the other is shear strain. Here the shear stress is force divided by area, and this shear strain is the change in length, this delta x, divided by the height. So both are in meters or whatever distance units, so they both would be killed, but we have different dimensional units. Here the length is dx on this direction, and here h is in this direction. But anyway, the units will cancel. So now we have shear stress, that is force divided by area. The force are 0.20 newtons, and the area is 6 centimeters times 6 centimeters, so 36 square centimeters, or 0.20 newtons times 36 times 10 to the negative 4 square meters. And the shear strain, this is 0.005 centimeters divided by 6. Sorry, I messed it up here. It was 5 millimeters. So it will be 0.005 meters divided by 6 centimeters. So 6 times 10 to the negative 2 meters. So meters are cancelled. This is the same as 5 times 10 to the negative 3. So this is this will be 5 over 6 times 10 to the negative 1. And here this is 2 times 10 to the negative 1. So I have here just 10 to the negative 3, and I have 2 divided by 36 would be 1 over 18. So I have 1 over 18 newtons per square meter. This is the shear stress divided by the shear strain, that is 5 over 6 times 10 to the negative 1. Here, sorry, I forgot, I'm dividing by 10 to the negative 3, 10 to the negative 3, and here 10 to the negative 1. The units are cancelled, so we have 6 newtons divided by 18 times 5 times 10 to the negative 4 square meters. So this is 3. I have 1 over 15 times 10 to the 4 square meters. So this is 1 over 3 times 5. This is 1 over 3 is 0.333, and 1 over 5 is 0.2 times 10 to the 4 square meters. So I have 0.3 times 0.2 is 6666. It will be 0.0666 times 10 to the 4 square meters. So I have 1, 2, 3, 4, 666 newtons per square meter. So the shear modulus of this cubic box with the applied force of 0.20 newtons, displacement of 5 millimeters, and the length of this box is 6 centimeters, is 666 newtons per square meter.